Hi everyone, my name is Ángel de Sousa Roque, and I'm going to talk to you about the laser welding cell that is the challenge in this class. Well, the first for all I'm going to talk to you about who we are. We are the Cellbotics sales, and basically we are a company that we have highly trained personnel in the programming and operation of the welding machine. And in this challenge, we are going to development a resolution for this challenge. And well, I'm going to start talking about our project. And as we can see, the first part of the project was to see what was the problem. And as we can see in the first picture, we have different parts in different colors. And in this picture is the right picture of the piece. And the process is well 28 points along all of the piece. And each piece of each color, we have to put it together in only one piece. And as we can see, we have two different pieces that are the same, but one is for the right and the other is for the left. And in this process, the second step is make a path. And for this, we use the program Robot Studio. And as we can see, the robot is welding each point. And for this, we have to cut and make a program so that the robot can make this welding. And then, well, that's the solution that we propose. And that's the beyond. That's how the robot works. Well, I'm going to continue. And as we can see, we have another view of our solution. And we can see the robot, we can see the fence, and we can see another elements about the safety and security of this project. And we have the fence, we have doors, we have the sensor of light, and we have different things that with this security things, we can work more safety, and it's a better solution for this challenge. And well, for the robot selection, accurate welding is required because it was the most important thing that we have to make. So the robot must be able to support the weight of the welding head, as we see in the video, that it was about 10 kilograms, if I am not wrong. And for this, we have to investigate the load diagram. As we can see, the x-axis, we have the meters of the robot can work, and the other hand, we have the load. So we can see for this robot, we have mostly like 10 kilograms, and we can see here the load diagram that the robot can work. Then we have here a list more specific of the tools and the parts that we have to need for make this project to happen. First, we have the fixture, and we have hold-on sound cooking, pliers, the hold-on clamps, and other elements. Then in the control cabinet, in this part, we have all the control of the process, and we have a more safety process. And we have the cabinet, relays, the battery charger, micro switches, control module, etc., and other elements that can be added along the process. And then we have the Zelda and the robot. The robot that we use is an IRB 2600 of 20 kilograms and 165 centimeters of range. So it is a very good choice, sorry, for the robot. And we also use two different isoplate beam cell, one large and another small. And for the safety, at the beginning of the course, we were required to use this international standards. That was the ANSI ERIA R15.006. But we can also use another regulation, as the NOM and the ENS ISO. Then we have to measure the risk assessment and the safety measure. This table, we can see all the hazards that can happen along the process. And we have different types of hazards. We divided in 7. The first one is machine startup. Then we have replacement of parts, activate table rotation, part displacement, robot maintenance, positioner maintenance, rinsing maintenance, area cleaning, and part inspection. The single one of these kind of hazard has his own hazards, as we can see here. And then along the different considerations as severity, exposure, avoidance, and risks, we assign the kind of each one of these. Then we propose a solution, as we can see in this part, and then we check again this standard, the exposure, the avoidance, the severity, and the risk. And we can see that in every single hazard, the ranking of each one of these is lower than before the solution. And finally, we have here the inside inspection. That is a very important part because we have to inspect every part of the welding. As we can see in the first picture is a correct welding that the robot made, and the other 3 images are wrong welding that the robot made. We made this bad welding inspection just to be sure that the inspection is a good inspection. So we can see we use the tool brightness and compare, and to make a result, we use the tool string. As we can see, we can hear a pass, and here we can see a fail. And we just not make one inspection, we make a second well inspection and a third well inspection. Then the final part of this challenge is propose an inversion and initial cost. And for this, we consider 4 important things, that is installation, fixture, robot, and control cabinet. As we can see, here are all the parts that we have to use to make this solution. And here we have the fixed and variable cost. As we can see the investments, the welding material, the break-even, and the break-even income. And with this, we can finally propose our solution of the challenge. And well, that's it. I'm very thankful for this course. I actually learned a lot, and we have opportunity areas to improve, but I think we make a a really good job, and I'm proud of my team. So thank you very much, and we are seeing soon.